Hey everyone, so this video is on ellipses. We define an ellipse as a set of points which are a fixed distance from 2 points, we call them the foci, that the sum of the two distances from any point on the ellipse to the two foci is the same no matter where you are on the ellipse. An ellipse can be constructed using a piece of string and two thumbtacks. Fix the two ends of the string so that the string is not tight, very loose. Then with a pencil, pull the string so that the string is tight and move the string around to form the ellipse. So if you take that string and you attach your pencil and then draw around it, that's the shape you get. You might think of the ellipse as the shape of the Earth going around the sun. The path it takes is an ellipse. And those 2 points that we have in the middle, they're called the foci. Okay, so we're going to be graphing ellipses, and we're going to put it in standard form and then graph. Very similar to the last section on ellipses, sorry, on circles. So a line that passes through both foci and intersects the ellipse at the 2 points, called the vertices, is known as the major axis. Okay, so the major axis, the foci go through the major axis. So you can look at our two diagrams that we have here. The one that says horizontal major axis, it's longer, right? It's longer widthwise. And the one with the vertical major axis, it's longer height-wise. So the foci are always on the horizontal major axis if it's longer horizontally, or on the vertical major axis if it's longer vertically. The minor axis is a chord that is perpendicular to the major axis, so it's perpendicular. And their point of intersection is called the center. So again, the major axis containing the foci is always longer than the minor axis. So those are called vertices on the major axis. I didn't write it, but the other ones are just called endpoints. So in these diagrams, the purple dots, or the purple endpoints that say vertex, those are called vertices, that's plural. And the two black dots, those are called endpoints. The red one is the center, and the blue focus points are inside the ellipse on the major axis. Okay, so we're going to talk about two standard forms now of an ellipse. The first standard form is with the ellipse having a major axis on the x-axis. Then we're going to talk about the standard equation when the ellipse has its major axis on the y-axis. So these next two standard forms that we're going to give are actually special cases. They're special cases where the center is at the origin. Okay, so that's not always the case. We're going to talk about when it's not at the origin in just a little bit, but first we're talking about these special cases just to kind of get used to what everything is here, okay? All right, so here's our standard equation. Again, with the ellipse has its center at the origin, 0, 0, and its major axis is on the x-axis, x squared over a squared plus y squared over b squared equals 1, where a is greater than b. And that's what's important, that the a is larger than b. Because a is larger than b, that means its major axis is on the x-axis. It goes farther left and right. So notice that underneath the x is an a, and underneath the y is a b. So associate the a with x and the b with y. The a will go left and right, just like x does, right? And the b will go which way? Up and down. just like y. Okay, in this case, the vertices are negative a0 and a0. So notice I put little purple dots for those vertices. And the endpoints of the minor axis are 0, negative b, and 0b. I use red dots for those endpoints. So the ones that are farther away from the center, those are called vertices. And the ones that are not as far are just called endpoints. Okay, the length of the major axis or the minor axis is 2 times the value of a or b. So for the major axis, it's 2a, and for the minor axis, it's 2b. Okay, the foci are at negative c0 and c0. Those are in blue. And again, they're on the major axis. And c is equal to the square root of a squared minus b squared. There's actually two formulas, one on the next slide that we're going to give. Just remember that inside the radical, you can never get a negative. If you get a negative, something's wrong. Okay, so just remember, I put a little note here next to the graph. A is left and right, and B is up and down. Okay, so now here's the standard equation with the ellipse having the major axis on the y-axis. Again, our standard form is the same. There's not really any change there. What'll be different is that the B will be larger than A. Because B is larger, that's what makes it go longer vertically. If the A is longer, if the A is larger, it'll be longer horizontally. Remember, A is your X and B is your Y. A is left and right, B is up and down. So again, it's the same thing. My vertices this time are on the y-axis, and that's because it's from the origin or from the center than the x values are, than the a values are. Okay. Almost the same thing, except the foci is now c equals the square root of b squared minus a squared. Again, it's because it's a larger number, so it's either a squared minus b squared or b squared minus a squared. You always put the larger number first. All right, let's do some examples, okay? Okay, our first example, find the center, vertices, the endpoints of the minor axis. By the way, if you just want to write endpoints, whenever we say endpoints, it's assumed to be of the minor axis. And the vertices, those are assumed to be on the major axis. And the foci of the ellipse, 4x squared plus 9y squared equals 36. So center, vertices, endpoints, foci. Okay, so the first thing we need to do is get the standard form. We don't have standard form because we don't have a 1 on the right-hand side. So first thing to do is divide both sides by 36 and simplify to get that 1 on the right-hand side. So rewrite your equation and then divide each term by 36. Okay, now we can reduce each fraction. 4 goes into 4 once, and 4 goes into 36 9 times. And 9 goes into 9 once, and 9 goes into 36 4 times. And then 36 divided by 36 is 1. Okay, now we have standard form. X squared over x squared over 9 plus y squared over 4 equals 1. Our center is 0, 0. Our a, well, to find our a squared is underneath the x squared, and b squared is underneath the y squared. So our a squared is 9, and our b squared is 4. Okay. Then to find out our a and b, we take the square root of that number, and that'll give you your a and b. So a is 3, and b is 2. Okay, what that means is a is underneath the x, correct? So that means the x is left and right. So we're going to go 3 left and 3 right from our center. And then since our b is 2, we're going to go 2 up and 2 down from our center. Okay, so go ahead and plot those points. 3 left, 3 right, 2 up, 2 down. And then we could draw our ellipse. It's almost a circle. The reason it's not a circle is because the a and b are different numbers. If the a and b were the same number, then it would be a circle. Okay, which ones are the vertices? The vertices are the points that are farther left and right. So in this case, our vertices are 3, 0, and negative 3, 0. Our endpoints are the ones that are not as far from the center. So that would be 0, 2, and 0, negative 2. The points that are farthest away from the center are the vertices. The points that are not as far from the center are the endpoints. Okay, one more thing to do is to find the foci. And the foci are always along the major axis. They're closest to the vertices, so they're near the vertices. Okay, so to find our foci, we're going to use c equals the square root. So it's going to be a minus in the middle. It's either a squared minus b squared or b squared minus a squared. You always want to put the large number first. So in this case, it's a squared minus b squared, or 9 minus 4. If you do 4 minus 9, you're going to get a negative, and that won't make sense inside the square root. So keep in mind, it's always going to be a positive value that we're left with inside the square root. So 9 minus 4 is 5, and the square root of 5 is approximately 2.2. We need to get a decimal approximation because you gotta count 2.2. So from the center, count 2.2 to the right and 2.2 to the left, and then plot your points. It's less than 2.5, so just get kind of close. So 2.2 to the right, 2.2 to the left. It's on the major axis. That's about square root 5. So if we label those points, it would be square root 5, 0, and negative square root 5, 0. The foci are always on the major axis, which in this case is the x-axis because the center is at the origin. Okay, let's move on. Okay, find the center, vertices, endpoints, and foci of the ellipse 25x squared plus 9y squared equals 225. Then sketch the ellipse. Okay, the first thing we need to do is put it in standard form. Very similar to the last example. We need to get a 1 on the right-hand side, so divide both sides by 225. So write down the equation and then divide each term by 225. Okay, now simplify the equation, reduce the fractions. X squared over 9 plus y squared over 25 equals 1. Again, our center's at 0, 0. Our next example will have a problem where the center is not at 0, 0. We're almost there. Okay, so now let's compare it to our standard form. Our center is 0, 0. Our a squared is 9. Our b squared is 25. Taking the square roots of those numbers, that'll give us our a and b. Center 0, 0. And our a is 3 and b is 5. Which way do we go for a? Right, a is left and right. And b is up and down. So 3 left, 3 right, 5 up, 5 down. I didn't say it earlier, but it's probably a good idea if you have graph paper. If not, you can make your own graphs. On the internet, you can find graph paper if you just want to print some up real quick. Okay, so 3 left, 3 right, 5 up, 5 down. Then draw your ellipse. Notice that this one has its major axis on the y-axis. It goes farther up and down. So we want to find our vertices. The vertices are the points that are furthest away from the center. So in this case, our vertices will be 0, -5, and 0, +5. The points that are furthest away from the center. Okay, our endpoints, well, that would be the other 2 points, -3, 0, and 3, 0. Okay, so we've got our center, vertices, our endpoints, almost there, right? The foci. It's always going to be c equals the square root, either a squared minus b squared, or b squared minus a squared. Which one will we use here? Right, b squared minus a squared. Our b squared is 25 and our a squared is 9. So that gives us square root of 16, which is 4. It's always on the major axis, so that means we're going to go 4 up, 4 down, for our foci. So 4 up and 4 down, that gives us our points 0, -4, and 0, +4. All right, let's move on. Here's our standard form. We're just going to write one at one time. This is for an ellipse that's not at the origin. So those other 2 standard forms, they were more of special cases. This is the formula you really want to memorize. X minus h squared over a squared plus y minus k squared over b squared equals 1. Kind of that same thing as the circle had, right? The h and k. Our center is hk. If a is greater than b, the ellipse has a horizontal major axis. And if a is less than b, the ellipse has a vertical major axis. And the foci, they always lie on the major axis and will be a distance of c units from the center. Okay, I put a lot of formulas here. Important ones are the center is hk, And I'm looking at the first graph on our left here. The vertices are h plus a comma k, h minus a comma k. The endpoints are h comma k plus b, h comma k minus b. All that's saying is we're starting from the center and we're adding a to the h value to get our vertices, and we're adding b to the y value to get our endpoints. And the foci, well, we're starting at the center, and we're always going c units left and right. So we're either adding c or subtracting c to get our foci. The graph on the right has a vertical major axis. We always start at the center. To get our vertices, we add b to the y value, which in this case is k. To get our endpoints, we add or subtract a to the x value to get our endpoints. To get our foci, which are on the major axis, we add or subtract c to the y value of the center. I know it looks confusing, and it is the way it's written. I totally agree. All we're going to do is count, and then we're going to figure out what point we're at. Okay. So we're just going to count. Don't be afraid. Again, we use our formulas. C equals the square root of a squared minus b squared, or b squared minus a squared. Okay, here's our first ellipse where the center is not at the origin. We're going to do the same thing. Center, vertices, endpoints, foci, and then sketch the ellipse. Okay, this is Oriented Standard Form. What is our center? Very similar to the circles, right? 2, comma, -3. And now let's find our a and b. A squared is 4, b squared is 16. So a is 2. Okay, so we plot our center, which is 2, -3. That's a red point that I have written here. And then we're going to go 2 left, 2 right, 4 up, and 4 down. Again, good idea if you have graph paper. So just count over 2, put a point to the left and right, count up and down 4 for our other points, our vertices. So 2 left and 2 right, that'll give us 0, -3, and 4, -3. And now 4 up and 4 down, that'll give you 2, 1, and 2, -7. See, all we're doing is we're adding 4 to the -3 to get our vertices. -3 plus 4 is 1. -3 minus 4 is -7. But it's easier just to count. 4 up, 4 down, 2 left, 2 right. Draw your ellipse. And then we could see that the vertices are 2, 1, and 2, -7. Our endpoints are 0, -3, and 4, -3. The points that are furthest away from the center are your vertices. The other points are our endpoints. All right, we're almost there. What's left? The foci. So we're going to use c equals the square root of b squared minus a squared. That'll be 16 minus 4, which is 12. The square root of 12, that simplifies to be 2 square root 3. Right? You can even use your calculator. Many calculators will simplify square root 12 and put it into radical form. And then you can hit that SD button to change it to a decimal. So it's about 3.5. Why do we need the decimal? Because 2 square root 3 doesn't mean anything to me. 3.5, that does mean something to me. It's always on the major axis, so we're just going to count 3.5 up and 3.5 down from your center. Okay, so we counted 3.5 up and 3.5 down. When we write our answer, it depends on your instructor how you want to write it. Many times they'll want to leave it in an exact form. That means don't simplify the radical, or don't write the radical as a decimal. Okay, so square root 12 was 2 square root 3. So that means we're adding it to the y value of the center. So the y value is at negative 3. So we're just putting negative 3 plus 2 square root 3 and then negative 3 minus 2 square root 3. The x value doesn't change. So that's why we have our foci at 2 comma negative 3 plus 2 square root 3 and negative 3 minus 2 square root 3. Or in decimal form, if your teacher wants decimal form, you can change those to decimal form if you want. 2 comma 0.5, 2 comma negative 6.5. A little messy there with the decimals, huh? Okay, let's do another one. Oh, sorry, not another one yet. That last problem that we did was in standard form. So now we need to talk about, well, what if it's not in standard form? Right, you know what we have to do. We have to put it in standard form. Okay, so if it's given in this form, ax squared plus by squared plus cx plus dy plus e equals 0 in law letters. We need to change it into standard form before graphing. So if you've done the video on circles, very similar. A little added complexity because we have a number in front of the variables that are squared, but we're just going to have to factor that number out. Okay, so the first step is we're going to move the constant to the right side and put our x's together and our y's together. Then we're going to factor the first number, which is a, from the x squared, and factor out the b from the y squared. And then we're going to make perfect square trinomials. Last time we didn't really have to factor out the a and b, but this time we will. And then we'll divide to get a 1 on the right-hand side. Okay, so make sure you pause the video, write down those notes, and then we'll move on. Okay, here we go. 4x squared plus 9y squared plus 8x minus 54y plus 49 equals 0. Okay, the 49, we're going to kick over to the right-hand side. We're going to put the x's together and the y's together. So that's 4x squared plus 8x plus 9y squared minus 54y equals negative 49. Okay, so we want an x squared in the parentheses, but right now there's a 4 in front of it. So what we're going to have to do is factor out that 4 from those two numbers. So factor out a 4 from the 4x squared plus 8x. And then how about the second binomial? We're going to have to factor out a 9 from those second two terms. Now when you do the next step, make sure you leave a space because we're going to add our own number that we want there by completing the square. Okay, so factor out a 4, that gives you x squared plus 2x plus a space. Factor out a 9, y squared minus 6y plus a space equals negative 49. Okay, now complete the square. So half of 2 is 1. Square it, you get 1. Half of negative 6 is negative 3. Square it, you get 9. So we're going to add a 1 and a 9. Whatever we add on one side, we have to add to the other side. But those two numbers aren't 1 and 9, right? They look like a 1. Looks like a 9. Not a 9, not a 1. What numbers are those? That's right, it's a 4 and 81. So you have to multiply the 4 times 1 to get 4, and the 9 times 9 to get 81. So plus 4 and plus 81. Okay, now we can write the trinomial, the perfect square trinomials, as a binomial squared. So that's 4 times x plus 1 squared plus 9 times y minus 3 squared, and that should equal 36 on the right. Okay, we need to get it in standard form, so divide each term by 36. Reduce the 4 and 36, the 9 and 36, and the 36 and 36. And that'll give you x plus 1 squared over 9 plus y minus 3 squared over 4 equals 1. So that is in standard form. Okay, we could graph that problem. We're not going to graph this one, we'll graph the next one. But you know what to do. What's our center? Our center would be negative 1 and 3. Negative 1 comma 3. What's our a? Our a is 3 because it's the square root of 9. Our b is 2. So from our center we would go 3 left, 3 right, 2 up, 2 down. It goes longer left and right. So that means our foci are also going to go left and right. Our foci, it would be a squared minus b squared, the square root of that. So 9 minus 4 will be 5. Square root of 5 is about 2.2, so you would go 2.2 left, 2.2 right. Anyways, we're not graphing that one, we just started talking about it. Let's graph the next one. All right, this is it. Last example. Find the center, vertices, endpoints, and the foci of the ellipse, 2x squared plus 9y squared minus 8x minus 18y minus 1 equals 0. Then sketch the ellipse. All right, first thing we need to do, put it in standard form. Group the x's together, the y's together, and then move the constant to the right-hand side. So 2x squared minus 8x, 9y squared minus 18y, and then the 1 is on the right-hand side. So what are we going to factor from the first pair? Right, a 2. Not a 2x, because we want to leave an x squared inside. So just factor out the 2. How about this second pair? Right, a 9. So factor out a 2 from the first pair and a 9 from the second pair. Okay, now we're going to use completing the square. Half of negative 4 is negative 2, and then square it is 4. And in the second parentheses, half of negative 2 is negative 1, and then we square it, we get 1. So we're going to add a 4 and a 1. So on the other side, not 4 and 1, but 8 and 9. Remember, you have to multiply the number in front of the parentheses by the numbers that we just added, and that will give you the numbers to add on the right-hand side. So 2 times 4 is 8, and 9 times 1 is 9. All right. So then in the parentheses, we want to write those trinomials as a binomial squared. So the first one will be x minus 2 squared. Second one will be y minus 1 squared. And on the right, we should get an 18. Now to get a 1 on the right-hand side, divide each term by 18. And then reduce. So x minus 2 squared over 9 plus y minus 1 squared over 2 equals 1. We've done it. Well, we're not done, but we've written the ellipse in standard form. I know, that was a lot of work just to do that. I agree. Okay, but we got to keep going. What's our center? And then what's our vertices and our endpoints? So our center is 2, 1. Plot that point. Our A and B, A is 3, and B is the square root of 2. I know, it's not pretty. Square root of 2 is about 1.4. So that means we're going to go 3 left, 3 right, about 1.4 up, and 1.4 down. When you label it, usually you want to label it in radical form. So you're going to add square root 2 to the y value and subtract square root 2 from the y value. So plus square root 2 and then down square root 2. All right, here are our 4 points. Going 3 left and 3 right gives you negative 1, 1 and 5, 1. And then going square root 2 up and down gives you 2, 1 plus square root 2, 1 minus square root 2. Again, we always add the radical to the y value when we're going up and down. Just like we added 3 to the x value going left and right. 2 plus 3 is 5, 2 minus 3 is negative 1. Okay, draw your ellipse. So which ones are the vertices? Right, the negative 1, 1 and the 5, 1, those are the vertices. And then the other 2 points are our endpoints. Okay, I wrote the endpoints in a condensed form. I'm not sure I'm even okay with it, but it's okay, maybe. Okay, so those are our endpoints. Endpoints and our vertices. What's left? Oh, right, the foci. Okay, so we're going to use a squared minus b squared. Yes, 9 minus 2. 9 minus 2 would be 7. Again, not a pretty number, but it's okay, we've got to deal with it. That's about 2.6. So when we plot our points, we're going to go 2.6 to the left and 2.6 to the right. Or another way of writing that, again, we're adding it to the left and right of the x value, which is 2. So it's 2 plus square root 7, comma 1, and 2 minus square root 7, comma 1. Again, it depends on your teacher if they want you to leave it in radical form, which is exact, or in decimal form, which you have to round. So approximately 4.61 or negative 0.6 comma 1 would be our foci. All right, it's all over. Kind of a long lesson, but this was our video on ellipses.